actually works these days. Okay, so what we're going to do today is we're going to be solving 5, 11, 21. Solving right triangles using trigonometry. Trigonometry. Okay. So, tons of applications, right? Tons. For instance, this could be a boy staying right here, and this could be a line attached to a pole, right? And we know the line is 12 feet, but we don't know how tall the pole is, right? So what we can do is solve this. So the first thing, always start with the angle, okay? Always start with the angle. So I'm just going to start here at B, okay? Angle B. Always start with the angle. And then let's give our sides names. Well, okay, if this is my angle, then this is going to be my opposite side, okay? So that's my opposite side. The 12, I already know the 12 is the hypotenuse. Everybody agree with that? And then this side is next to me. It's called the adjacent side, okay? How am I doing? Antonio, am I good? So we can also, instead of calling the side AC in trig, we just kind of make it a little bit easier. Since this is angle B, we label all the angles in capital letters. All the angles are capital letters. So this is also side B, little b. This would be side A, and this would be side C, okay? So we just label the sides also as the small case letters. Angle B, little b. Angle A, little a. Angle C, little a. So that's, instead of calling it AC, let's call it little b. Instead of calling it CB, let's call it little a. Instead of calling it AB, let's call it C, okay? Now, let's solve this thing, okay? Well, first of all, we could either find the opposite side or the adjacent side. It does not matter. It does not matter at all. Let's find the opposite side. It does not matter. You can find either one. So if I choose to solve my opposite side, I need to probably use the 12, okay, because that's my hypotenuse. Okay, we'll get the adjacent second, okay? So what I do is I go to the angle, and then I decide which side I want to solve for. And I have to use the side I know, because I need information, I need numbers, okay? So after I decide from the angle, I want to solve for this side, I need to use what I've given. Then I say, okay, well, I look up there, and I ask myself, what do I have? Well, it looks like I'm going to find the opposite hypotenuse, right? We're not going to do the adjacent yet, opposite hypotenuse. Which one am I going to use? Everybody agrees? Sine? Has to be sine, so I look up there, I'm going to use sine. So it says sine of theta is equal to the opposite over the hypotenuse, right? Now let's put the numbers in where they belong. Theta is a symbol for an angle, so I'll put 65 degrees for theta. The opposite we'll call little b, that's the symbol I use, and the hypotenuse we'll use 12, okay? All right, so I'm going to go, okay, sine of 65 is equal to the opposite, which is b over 12, okay? So if I got it set up, and I'm going to grab my calculator. You're going to need a calculator, okay? Anybody need a calculator? Okay, you're going to need a calculator. Guys, you're going to need a calculator to do this. So if you want to grab one. Okay? So I am going to multiply by 12, because that's how I solve it. Times it by 12, times by 12. And that way b is going to equal 12 times the sine of 65. Okay, so I want you to put that in your calculator when you get a calculator. Okay, so I'm just going to go, all right, I can do this. I go 12 sine of 65. Okay, everybody type that in your calculator, just like that, okay? Now, if you don't get 10.87 or 10.9, let me know. If you get a different answer, let me know, because you might be in the wrong mode. Everybody get that answer? Okay, there's a mode button in your calculator, which is degrees or radians. You definitely want to be there. Okay, so we get about 10 point, we'll round it up to 10.9, okay? So this side, little b, is 10.9. Okay, now if I know this side, right, and I want to solve the entire triangle, right, then what I would do is say, okay, if I know this side's 10.9, I know this is 12, I could probably find this other side by Pythagoras Theorem or by trigonometry. One or the other, right? What do you think? Do you want to do Pythagoras Theorem or trigonometry? Because I could use cosine to find this side. Let's do trig, because you could use Pythagoras Theorem, but let's use trig. I'm going to now, instead of using my opposite, I'm going to find my adjacent, which is little a, and my hypotenuse. So if I adjacent and hypotenuse, I look up there. Adjacent hypotenuse, let's use cosine. Might be, so if I go cosine of theta is equal to my adjacent over my hypotenuse, I can find my adjacent side by using trig also. Or I could have used Pythagoras Theorem. Okay, so then I'm going to go cosine of theta. Let's go cosine of 65 is equal to my adjacent side, which I don't know. I'm going to call it little a, over the hypotenuse, which is 12. And I'll multiply up the 12, multiply by the 12, and I will get a to equal whatever 12 times the cosine of 65 is, right? Oh, now, okay, 12 cosine 65, what do I get? About 5.07, we'll round it to 5.1, okay? So this side is a little a, is a 5.1, okay, good. Now, I've got one last thing to find, and that's angle A. Now, that should be the easiest of all. Finding angle A should be super easy. I know in a right triangle, so angle A, in a right triangle, there's 180 degrees, correct? Everybody agree? 180 degrees in a triangle, but I already got 90 of it used here, so if I just take 90 and subtract from 65, it's faster, okay? These two angles are complementary, meaning they add up to 90. So, all right, the easiest way to find angle A is just simply go 90 degrees minus my 65 degrees. What's that? 15, 25, 90 minus 65 must be 25, right? Yeah, 25 degrees. Okay, thumbs up. Do you guys think that's pretty easy? There's one thumb up. Awesome. Anybody else? Okay, let's practice it one more time. Okay, so we've got this triangle. Triangle PIG, my piggy triangle. And always do what first? Come on, tell me. What do you do first? What should you do first to tackle this triangle? Start with the angle. Yay! Thank you, Abby. Start with the angle. Okay, and then you can label your sides. Okay, now this side here would be my opposite side, right? My hypotenuse. And this would be my adjacent. Okay, you guys agree with that? All right. It does not matter. Antonio, do you want to find the hypotenuse or do you want to find the adjacent? It does not matter. That's why I asked you. It doesn't matter. Which one do you want to find? The hypotenuse or the adjacent? What's that? The hypotenuse it is. Okay, so we'll call it little g. All right. So if we decide to go for the hypotenuse, like that, we're going to use the opposite, right? Let's use the number we know. And I've got, again, my opposite and my hypotenuse, right? My opposite hypotenuse, which means which am I going to use? I look up on the board. Which one am I going to use? Ellie, go ahead. Sine again. This time sine. One more time. So we're going to set up sine of theta equals my opposite over my hypotenuse, because I want to use the side I have and I want to find the hypotenuse. Okay, now let's put things where they belong. Theta means angle. My angle is 28, so I'll rewrite this as sine of 28 equals my opposite, which is 5, over my hypotenuse, which I don't know, I'll call it g, right? Now I'm going to multiply it by g, but that won't solve it yet. Okay, if I multiply it by g, so if I multiply both sides by g, in a sense, I'm just multiplying g up here, okay? And then I get an answer of g times the sine of 28 equals 5. Now, sine of 28 is just a number. It's a number in our calculator, right? So if it's g times sine of 28, that's just a number. It's some number in my calculator, some decimal. In fact, what the heck? I'll just show you real quickly. Sine 28, right? It's just some decimal, right? So if it's just some decimal number, let's just, to solve for g, let's just divide by sine of 28 and divide by sine of 28, and I'll have g is equal to, well, whatever that is, whatever 5 divided by sine of 28 happens to be, and I'll use my calculator. I'm just going to divide. So watch. I'm going to go 5 divided by sine 28. I can answer about 10.65. Okay, make sure you guys get it. I want to make sure everybody pushes the numbers correctly. Thumbs up. Everybody get 10.65? Good. Okay. Okay, now let's find the adjacent by Pythagorean theorem, because I want to show you both ways. What's that, Ellie?
Can you slow down for a second?
I sure can. Let me write this down. 10.65. I will slow down. Wait for you. Okay, now let's find little I. That's the name of it. If that's angle I, then that's little I. I'm just going to use Pythagoras theorem this time. It's just, or I could use cosine, but let's go I squared plus 5 squared equals 10.65 squared. I just want to show you both ways to do it. Or I squared is equal to 10.65 squared minus 5 squared. I'm just going to let my calculator do the work, right? All right, let's just let the calculator do the work. So we're going to go 10.65 squared minus 5 squared, right? And I should get an answer, but then that's I squared. Goes my 88.4225. And then, of course, square root it, right? Because that's I squared. So to solve for I, we'll square root both sides. And square root that answer. I got about a 9.4, okay? 9.4. Little I is about 9.4 centimeters, inches, whatever. Okay, the last thing I have to do is find angle I. Well, that's easy, right? If I need to find angle I haven't found angle I yet. So if I got to find angle I, let's just subtract from 90, right? Subtract from 90. These two angles have to add up to 90, so for angle I, I'm going to go angle I is equal to 90 degrees minus 28 degrees. And I can answer about 62 degrees for angle I. Okay, give me a thumbs up if you're with me. Okay? So trig's not that hard, is it? No, it's not really that hard. You should have learned it last year or last semester, but it was a blur, right? Maybe you learned it, maybe you didn't, okay? Okay, turn the page. That's why I'm taking the time to do it one more time, okay? Now, example 3. Write this down. Write this down. Star. To find an angle, use, we're going to call it trig inverse, okay? Trig inverse, meaning sine inverse or cosine inverse or tangent inverse, depending, okay? I'm going to highlight that, okay? So you're going to push one of these 3 buttons when you want to find an angle. It's just the opposite. It's the inverse. So if we have a side, we can find an angle. That's the opposite of having an angle and getting a side. All right, so if I take a look, and I want you to see these buttons, okay? So on my calculator, in blue, do you guys see it in blue? Sine inverse in blue. Cosine inverse in blue. Tangent inverse in blue. And you can do this on your phone, but it's not as easy to do on your phone. Okay, so let's figure out an angle, okay? So either angle X or angle Y. It does not matter which one you pick, okay? Olin, what do you want to find? Y or X? Does not matter. Angle Y or angle X? Which one? X it is, okay? Now, we have some sides, so let's give them names. I know the 8 is my opposite, because you picked X, right? So that's my opposite. I've got my hypotenuse, and this is my adjacent, okay? Antonio, if he had picked Y, then my opposite would be a different number, right? Okay, good. So if we want to find angle X, and these are the 2 numbers I have. I've got my 8 and my 7. So what I have is my opposite and my adjacent. So if I have my opposite and adjacent, look up on the board, which one should I use? Opposite adjacent, opposite adjacent. Which one is it? You guys agree with tangent? So it should be tangent of theta equals the opposite over the adjacent. Okay, good. And then we know the opposite is 8 and the adjacent is 7. So I'm going to rewrite this as tangent of x, because that's my angle, right? Tangent of x is equal to my opposite, which is my 8, over my adjacent, which is 7. Now, I'm going to look up here. If I want to find an angle, I have to use that inverse button. So I'm going to rewrite this as tangent inverse of 8 over 7 will equal angle x. Okay, so let's put that in our calculator. I need the inverse button, which is these little blue ones, right? So I need to get the blue button, so I use the blue button here. Okay, so I'm going to go second tan. Okay, so you need that. See the little negative symbol? You've got to have that of 8 divided by 7. Okay. All right, 48.8 degrees makes sense. Okay, if you get an answer that's a weird answer, then either you made a mistake or you have the wrong mode. So 48.8 is angle x. All right, now let's see then if we can find angle y. How would you find angle y? Well, these two have to add up to 90, right? 48.8, so angle y is equal to 90 minus my 48.8. All right, so we just go 90 minus 48.8, and I get 41.1. So angle y equals a 41.2 degrees, okay? And then finally, if I want to find this hypotenuse, Pythagorean theorem, right? Let's find a squared plus b squared equals c squared, or we'll go 7 squared plus 8 squared equals my hypotenuse squared, which is really z, little z. Put that in my calculator, right? I like trig. Trig's fun. 7 squared plus 8 squared, okay, take that, 113. Square root, right? And I take the square root of that, and I get an answer about 10.63 or 10.6. What do you think? Give me a thumbs up. Can you do this? Okay. Last but not least, okay, trig really is used. It really is. So here's an example. Okay, a 6-foot man sights the top of a tower at an angle of elevation of 77 degrees. Okay, if he's 200 feet away, how tall is the tower? Okay, so let's draw a picture. We know we need a right triangle. So here's my tower. Okay, so just put my tower here. This big old tower, right? Here's my man. He sights, standing there. Okay, so he sights the top of the tower. That's my tower. And he's 200 feet away. Okay. Now, because he's a 6-foot man, the triangle that we're looking at is suspended 6 feet above, okay? I've got 77 degrees here, 200 there, so 200 is also here. So when I get my answer, I'm going to add in the 6, okay? When I get my answer, I'm going to add in the 6, because that 6 feet is, because he takes it from his eyeball, right? So let's figure out what the tower is, okay? So let's see. Go to my angle. The tower is my opposite side, right? My 200 is my adjacent side, right? So again, opposite adjacent. Which one is going to be up there? Opposite adjacent. Tangent, right? So we'll set up tangent of theta equals my opposite over my adjacent, right? But theta is really my angle, so I'm going to put 77 there, and my tower we'll just call it t. So I'm going to go tangent of 77 degrees is equal to my opposite, I'll call it t for tower, over my adjacent, which is 200, right? And now, just going to multiply up by 200, multiply by 200, multiply by 200, and I'll have 200 times the tangent of 77 degrees equals t. We'll use our calculator. And I got it 866.3. Now we're not done. 866.3 because we also have to add in the 6-foot man, right? So what is that? 872.3 feet tall. I think it's in terms of feet, yeah. Okay, that's what I have. So homework today is going to be it's a worksheet. I better show it for the kids that are online. Better go ahead and load it up. So I got a worksheet because supposedly we learned this last year, and this particular book seems to think you guys remember it, but I know you don't. So I'm going to pass this out, and kids online, it's going to be in your packet, okay? Or it's going to be in Canvas.